Along the same lines of I squared being equal to -1, we can do the same thing with I to the third and I to the fourth. So just a really quick little example here of each one. So I to the third, because I is square root of -1, is square root of -1 times square root of -1 times square root of -1. And if we go through and do this, and we really have to think about it here, these two square roots of -1 will multiply together to give me a -1. So what I end up with is this, all right, because these two square roots give me -1 when I multiply them together. So if I have -1 times square root of -1, that's the same thing as -I, because this square root right here is equal to just the I, all right? And again, it's kind of a weird thing, but I is a number, even though it's a letter. It's representing a specific number. So we have to be able to do it with powers, all right? So what that ends up telling me is I to the third is -I. So right now I have I squared is -1, I to the third is -I. And if I go to I to the fourth, I end up with 4 square root of -1s all multiplied together. And what happens with this is these two right here give you a -1. And these two right here give you another -1. So it ends up giving you -1 times -1, which means that that's altogether equal to 1. All right. And then what that leaves me with is I to the fourth is -1. I to the third is -I. And I to the second is -1. All right, and then obviously I to the first is I. These 4 things right here, all right, could lead me to having to do super ugly things with like I to the fifth, I to the seventh, I to the 100th, all right, but it doesn't, because what this thing does is it keeps repeating. So when you get to I to the fourth is -1, it then just jumps back and starts over again. So I to the fifth, I to the sixth, I to the seventh, I to the eighth just match up. So I to the fifth is just equal to I to the sixth is -1, I to the seventh is -I to the eighth is 1, and then it just keeps cycling around again. So every time you have an I to a power, it either gets replaced with a 1, a -1, a -I. Now that I'm looking at this, I don't have a dot on top of that. A -I, or a 1. All right, so I have to do that. Now, it could come up, and that could be super, super hard. All right, but the good news is there's a few different ways to do it, but the best way is just do a division with the exponent. All right, so if the exponent, for example, is I to the 17th, you do 17 divided by 4, and you're going to get a number. In this case, you'd get 4.25. All we care about is the decimal. All right, a 0.25 means it's an I to the first. A 0.5 means it's an I to the second. A 0.75 means it's an I to the third, and a 0.00 means it's an I to the fourth. All right, now again, you gotta memorize that, just like everything we do in algebra. All right, we have to memorize all these rules and be able to apply them. All right, and they're not anything that you can just kind of understand without really memorizing the specific thing. All right, but what ends up happening is every time we have this, we're going to replace these i's with either I, -1, -I, or 1, and then combine like terms. This takes practice. Once you practice it a bunch, it'll come down to if you actually know this little chart right here with the 0.25s and the 0.5s. If you know it, it's a pretty quick substitution. If you don't, it becomes much, much more